the gas goes up to displace the water inside the graduated cylinder. As you can notice, these bubbles starting. Hey, you're wonderfully welcome to Her Majesty Easy World Science channel. In this video, I'll be demonstrating how to collect gases over water and also measure accurately the volume of gas liberated from a given reaction. What you have to do is that you have to bring a graduated cylinder and fill it with water. Fill it such that there won't be any space. Fill it completely to avoid error in the volume. Then cover with a watch glass and invert it over a trough of water. Avoid enough air bubbles. Don't allow any space if you need accurate measurement. Then I added more water to the trough to make it fill enough so I can lift the graduated cylinder that I inverted and now insert my delivery tube into it. The delivery tube is connected to the reaction flask, which is, I'm using Buchner flask here because it has the side arm. You can substitute it with even test tube with side arm. It can equally do that. Then this reaction, I'll be measuring the volume of oxygen liberated from the reaction between acidified potassium tetraoxomanganate 7 and then hydrogen peroxide, because I'm actually investigating something which will be another video altogether. So I want to add about 8 to 10 ml of 0.01 molar KMnO4. This is 0.01 molar of KMnO4 into the Buchner flask, and then I have to wash with water, meaning to rinse it, making sure that the whole KMnO4 I measured gets into the bottom of the reaction vessel to ensure complete reaction. Then I have to acidify with H2SO4. Remember, if you don't acidify with H2SO4, the reaction will go otherwise. It will not be just decomposition of hydrogen peroxide, where KMnO4 will act as a catalyst, but acidifying it makes KMnO4 act as the oxidizing agent. So I added more delivery tube so that I can narrow down my liquid into the other reactants, such that gas will not be evolved from the same delivery tube. From the same delivery tube, I'm introducing my hydrogen peroxide. So I have to fill the dropping funnel with hydrogen peroxide. And with this, everything is set up. The next is to open the tap and see the oxygen gas being delivered over water. I'm collecting it over water. The gas goes up to displace the water inside the graduated cylinder. As you can notice, these bubbles, that is oxygen gas. And the volume of water displaced is exactly the volume of oxygen gas liberated. You see, I've shaked the reaction vessel and the reaction is now colorless because the hydrogen peroxide has reduced the KMnO4 to manganese 2, changing it from purple to colorless. So the more I introduce the hydrogen peroxide, the more the bubbles. And then this is a kind of a Udometer. We use it to measure accurately the volume of gas liberated, and this will ensure accuracy. Your job is to do your mathematics well. I'll still make more video on this experiment I'm doing. This one I'm showing wasn't 100% accurate because there were little bubbles as I was inverting it, and the measurement of the KMnO4, it wasn't exactly 8, neither is it 10, but it's really 8 to 10. But it's giving me a range of what I want to see the volume of gas evolved so far. And I'm not sure whether the whole reaction is complete because I've exhausted my hydrogen peroxide. The same procedure, but I replaced the graduated cylinder, which is made up of glass, with plastic. This is still the same mechanism. Shaking it well. The solution decolorizes. So thank you for watching. I've demonstrated 2 things in this video: production of oxygen gas and collection of oxygen gas over water.